Okay, so let's start kind of walking our way through this check problem on page 327 in your notes. We are supposed to find the measurements of angle XYZ and YZX. So let's go find those two angles and then see what we need to do to find them. XYZ, so Y is going to be my vertex. So XYZ, I'm going to start at X, go up to Y, and then down to Z. So this is one of the angles that we are supposed to find right here. And then the other angle that we are supposed to find has Z as the vertex. So I'm going to come over here. We're going to start at Y, then go down to Z, and then over to X. So right down here is the other angle that we are supposed to find. How many angles do we know in this picture? Go ahead and answer for me in the chat. How many angles do we know the measurements for? How many angles do we know the measurements for? That's right, one angle. It's this angle X over here. We know that this is a 90-degree angle. We don't know, other than that, what kind of triangle we're looking at here. I know it's a right triangle, but I don't know if it's a right scalene triangle. I don't know if it's a right isosceles triangle. So what we need to do is to come here and find our ordered pairs for X, Y, and Z. And we're going to find the lengths of these three sides so that I know what kind of triangle I'm looking at here. All right, so X, let's see, 1, 2, 3, so -3, and then 1, 2, 3, 4. -3, 4 is my ordered pair for X. The ordered pair for Y would be 1, 2, 3, 4, 5, 6, 7, 0, 7, because we don't go left or right at all, you just go straight up 7. And the ordered pair for Z would be 0, 1. Now, one of these three sides, we can just count to see how big it is. Which of these three sides can we just count to get the size of? XY, YZ, or XZ? Which side can we count to see how big it is? YZ, absolutely. It's laying right on top of those grid lines. So we can count here, 1, 2, 3, 4, 5, 6. This would be 6 units. So we are going to find the length now of XY. And then we are also going to find the length of XZ. If I don't know what kind of triangle I'm looking at, especially if it's on a grid like this, on an XY plane, we're going to need to use our distance formula so that we know how big the sides are. And that's what I'll use to figure out what type of triangle I'm looking at. All right, so I'm going to let -3, 4 be my X1 and Y1. And I'm going to let Y be my X2, Y2. So in my distance formula, we do X2 minus X1. So that'd be 0 minus -3, close my parentheses and square it, plus Y2, which is 7, minus Y1, which is 4, close my parentheses and square it. We're going to simplify those parentheses next. 0 minus -3, well, when I subtract a negative, that turns into a plus. So I have 0 plus 3 quantity squared. So that is 3 squared plus 7 minus 4 squared. Well, 7 minus 4 is another 3. So that's 3 squared. What is 3 squared? Go ahead and tell me in the chat. What is 3 squared? 9, thank you. So I have 9 plus another 3 squared, so 9 plus 9. What is 9 plus 9? 18, thank you. And when I pop that into my calculator, the square root of 18 is about 4.24. So this side over here, from x to y, is the square root of 18, or about 4.24. Then we're going to do the distance formula for xz to figure out how big that side is. So I'm going to go ahead and let x be my x1, y1 again. And I'm going to let z be my x2, y2. So x2 is 0 again, minus x1, which is negative 3. So 0 minus negative 3, quantity squared, plus, and then I have 1 minus 4. Close my parentheses and square. Remember, it's x2 minus x1 squared plus y2 minus y1 squared. So underneath my radical, I'm going to simplify these parentheses. 0 minus a negative minus negative turns into a plus. So I have 0 plus 3, or 3 squared, plus, what is 1 minus 4? Negative 3. So I have negative 3 squared. You guys already told me that 3 squared is 9. What is negative 3 squared? Negative 3 times itself. What is negative 3 times itself? Negative 3 squared. Positive 9. Thank you. So 9 plus 9, I get square root of 18 again, which, as we already mentioned, is about 4.24. I got that by popping it into my calculator. So this side down here is the square root of 18, which is about 4.24. What kind of triangle are we looking at here? What type of triangle are we looking at? I know that one of my sides is the square root of 18, 4.24. I know another side is 6, because we counted that one. It was right on top of the grid lines. And the third side is square root of 18. Absolutely correct. This is a right isosceles triangle. So I have xy is congruent to xz. So this is a right isosceles triangle. Because we have two congruent sides, we're going to have two congruent angles. Which of my angles will be congruent to each other, x, y, or z? Which two angles will be congruent to each other? Which two angles will be congruent to each other? Y and Z, thank you. We follow this across the triangle. So here's one of my two congruent sides. We do the same thing with the other congruent side right here. XZ, we follow that across to the opposite angle. This is my other congruent angle. Does that mean that my angles are the square root of 18? Are my angles the square root of 18? No. When we say they're congruent, we don't mean that they are congruent to the sides. We mean that they are congruent to each other. All right, so I've got the measurement of angle X, Y, Z plus the measurement of angle Y, Z, X plus the measurement of angle Y, X, Z is equal to 180 degrees. Remember, we're supposed to be finding these two angles. We're supposed to find XYZ and YZX. Do we know how big XYZ or YZX is? Do we know the sizes of either of those angles? No, we don't know the size of either one of those angles. So if I don't know how big they are, but I know they're the same size as each other, what should I call them? I don't know how big they are, but I know that they are the same size as each other. So what could I call them? I can call them X. So I have X degrees and another X degrees. That's these two angles that we're looking for. So X degrees plus X degrees plus, how big is angle YXZ? How big is angle YXZ? Remember, X is the vertex because that's in the middle. How big is angle YXZ? That's right, 90 degrees. So X plus 90 equals 180. We're going to combine our like terms together here, and while I'm at it, I'm going to subtract 90 degrees from both sides. So I have 2x is equal to 90 degrees. I'm going to divide both sides by 2, and that means x is how big? How big is x? Absolutely, 45 degrees. Thank you. We were letting that stand in for both of the angle measurements that we're supposed to be looking for because we knew that those were congruent angles. So both of those angles that we were asked to find are 45 degrees. Wonderful. All right, let's go ahead and turn over to page 328. On page 328, we are supposed to find the measurement of angle J, which is way up here at the top. Looking at what they have printed on here for me, what kind of triangle are we looking at? Is this scalene? Is this isosceles? Is this equilateral? Just based on what they have printed for me, what are we looking at? It's an isosceles triangle. We know that side JL is 12 feet. And we know that side JK is also 12 feet. So this is an isosceles triangle. That means I'm going to have two congruent angles when I have two congruent sides by the isosceles triangle theorem. That means I'm going to have two congruent angles. So let's go ahead and write down what we've got, because JL, measurement of JL, is equal to the measurement of JK. That means segment JL is congruent to segment JK. By the isosceles triangle theorem, our base angles, which are L and K, are congruent. Again, we follow these across. So here's one of my congruent angles, and then I do the same thing with the other side. This congruent side, we go across to the opposite angle. So if angle L is 60 degrees, how big is angle K? These are my two congruent base angles. $60 degrees, thank you. So then we can use our triangle sum theorem, which your book has set up for us. The measurement of angle J plus the measurement of angle K plus the measurement of angle L equals 180. We know that K and L are both 60 degrees. And then your book kind of shortcuts the rest of this. I'm going to combine my like terms together here. I'm going to combine 60 and 60 together and get 120. So the measurement of angle J plus 120 degrees equals 180 degrees. I'm going to subtract 120 degrees from both sides, and I find out that angle J is how big? $60 degrees, thank you. So that means all three of my angles are 60 degrees. If I have three congruent angles, what kind of triangle am I looking at? Three congruent angles would mean I'm looking at what kind of triangle here? Absolutely correct. This is an equilateral triangle. This means I would have three congruent sides as well. So it's an equilateral triangle. I want you guys to make a note up at the top here for example number 3. In an equilateral triangle, all three angles will always be 60 degrees. Why do you think that is? Why would all three angles be 60 degrees in an equilateral triangle? Why couldn't they all three be 50 degrees or all three be 80 degrees? Why do they have to be 60 degrees if it's an equilateral triangle? Absolutely. Because a triangle has to add up to 180 degrees, and the only way I can have three angles that are the exact same size that add up to 180 degrees is if all three angles are 60 degrees. So if all three angles are 60 degrees, it's an equilateral triangle. If I know that all three sides are the same size, that automatically means that all three angles would have to be 60 degrees. All right, let's go look at the check problem at the bottom down here. Or sorry, not the bottom of the page, but just underneath that problem. Looking at this triangle, I see that side PQ is the same size as side QR. They are both 5 centimeters. So I have two congruent sides. By the isosceles triangle theorem, that means I have two congruent angles, and I'm going to follow these sides across to the opposite angle. So PQ, I'm going to follow across to this angle. That would be angle R. And side RQ, I'm going to follow across to the opposite angle. That would be angle P. Those two angles are going to be congruent to each other. And I know that angle Q is 60 degrees. So the measurement of angle Q plus the measurement of angle P plus the measurement of angle R is equal to 180 degrees. I don't know how big P and R are, so I'm going to let X stand in for that. So I would have 60 degrees plus X is equal to 180 degrees. I'm going to combine my like terms together, X and X. I'm going to subtract 60 degrees from both sides. And so I have 2X is equal to 120 degrees. Divide both sides by 2, and I get that X is 60 degrees. Since I was letting X stand in for the sizes of both P and R, I know that angle P and angle R are both 60 degrees. So angle R is 60 degrees. We have 3 congruent angles. So that means 3 congruent sides, which means side PR is how big? How big is side PR? 5 centimeters. That's absolutely correct. Side PR is 5 centimeters. We are working with an equilateral triangle here. All right, you guys have homework that is due for me tomorrow when you come in. If you do not know the sizes of the lengths or the sizes or lengths of the sides of triangles and it's on a grid, you're going to have to use your distance formula to find that. The homework you can do on the worksheet that you picked up in class, or if you forgot the worksheet but you have your book at home, you can do pages 329 to 331, the following problems. You can find that in the slideshow presentation up on my screen right now, or you can also find that in Canvas. If you go to the assignments tab, this is module 5, homework number 3, and it's got those problems written out there. I hope you guys have a fantastic rest of your day. Please let me know if you have any questions about anything.